All right, ladies and gentlemen, welcome back. Um, I'm going to start doing live streams for these videos from now on, just so there's no delay for the resolution upscaling. So, like when you post a video to YouTube, the first one that's available is like 360p. You can't make out any of the code at that. And I'm wondering if that's pushing away people from watching the content. So I'm thinking what I may end up doing is live streaming it at 1080p from the get go. And then as soon as it's available on YouTube, or if someone comes across it in live, they'll be able to see everything I'm doing. Plus, if I mess up, you'll be able to see it live and know that a lot of this stuff, when I do mess up, is not thought about. It's just something that just randomly happens, and we work to fix it. So the first thing I'm going to do is I'm going to guarantee that the stream is working. So if you hear an echo, just ignore it for now. I want to double check the quality because I just had an issue, and if everything's good, we'll continue on with the video. So just bear with me like 30 seconds. We'll continue on with the video. So just bear with me like Okay, everything appears to be good. So I'm going to turn. I'm using my cell phone for chat because I don't have a second monitor at the moment. So I'm just using my cell phone for chat, which it'll work just fine. So anyway, in this video, what we need to do is we need to finish up the networking part of our application. I did promise that we would use this with raw WinSock. We need a TCP resolver. I'm thinking what I may end up doing is just creating a TCP socket, just like a blanket one that you can connect, bind, listen, and I think we already did that here. And so TCP socket, I'm just creating it and throwing a system error if something bad happens. Shutting down, it just shuts down. We have accept, which can accept a connection, and it just returns a TCP socket. Bind binds to an address. If it fails to bind, we throw an error. We can listen. We can connect. Yep. And we can send data. The send and receive, I'm actually going to rewrite. Just because I did play around with Boost a little bit this past week, and I kind of like just using the raw stuff and then building abstractions on top of that. So the way I'm going to do this is just called send and then const void pointer buffer constant length constant flags equals 0. Okay, so now that we have that, I'm also going to mark these functions as no accept, and it's up to you to determine whether or not an error was thrown. But this is just because this is going to be like a low level abstraction for sending. I mean, the connecting to clients and stuff like that is completely fine. So then we need another int for receive, and we void pointer buffer constant length constant flags. We'll mark this as no accept too. And here, all we're going to do is just return receive. We need the reinterpret cast at the char pointer, length, and flags. And then we'll just do the same thing here. We'll do m socket get reinterpret cast const char pointer buffer length flags. Okay, so now we have a really low level. So if you call this function, and actually I can do you one better, force inline these, and there's no overhead. It's just using the TCP socket API. So I know this is using raw pointers and stuff like that, but don't worry. This is just like, I want this to be almost as low level as humanly possible. And I'm also not going to throw exceptions here either. What I'm going to do instead, so this way this entire thing can be no accept. And then here we're just getting our endpoint. And we'll just guarantee that it does not equal socket error. And we'll just do the same thing here. And the only reason that I'm doing these is because they're one-liners. The interface is a little more clear, and everything should be in lines just because they are one-liners, so everything should be fine. in here, just return listen in msocket.get, and we'll pass in our backlog. And again, does not equal socket error. Okay, binding, same thing. And again, what we're doing is we're making these calls here as low level as possible, but still wrapping them in like a fairly easy to use interface. And the only reason I'm doing this is because, again, we're using IPv4 for the entire application and TCP. So having this without having to type reinterpret cast over and over again and passing in the size of things, this would just make it a lot easier for us. This needs to be bool. And we'll go ahead and mark this as no accept, and we'll inline this. We'll make this bool. Will allow you to set what actually happens. We'll shut down how, and we'll simply return does not equal socket error. And here, we'll just simply shut down. The default call does both. I'll get rid of this indirection here and just comment that we're using this shutdown. This constructor will throw. I'm going to add a constructor that will not throw. And we don't have to check anything. All we got to do now is we just need a couple of functions that will help us out along the way. I'm just going to inline everything. Again, keep this as low level as possible. We need to redo that one, the accept function, but I also think is valid. It's just because I remember what I typed. Explicit operator bool. All right, so that should be those. Now we have to work on our accept. Again, I'm going to inline. And I'm going to have two. I'm going to have basically two accept functions. One that will throw an exception and one that will not. I don't know a better way to do this since you are constructing a TCP socket. So here we're simply creating the socket. We're throwing an exception. So I like this. But this one here, I don't want to throw an exception. Instead, I'm actually just going to return a regular TCP socket like this. And what this will do, this will not throw an exception. So you will have to check yourself if you specify no throw. And then we want to be able to get the address. Get peer socket address, which is basically if you're connected, this gets the IP of the peer. So we are going to create a sock address underscore n address and length size of address is it get sock name? Yep. Socket name, reinterpret cast, socket address pointer. And simply just return the address. Now this I can copy and paste and just simply change this function name from get sock name to get peer name. And peer name, again, it gets what your socket is connected to. So if there's a remote connection, this will get that IP address. Let's see here. What else do we need? Again, ignore this. We went over this in the last video. There's something weird right now with modules and IntelliSense. It's saying that this is an error, like it doesn't recognize this type, but that's not true. You can see in the last video, we ran the code just fine. When we hit debug, everything ran perfectly. All right, so now that we're like virtually just making native calls here, and we're just wrapping them kind of nice and neat. Again, we have a couple of exception throwing functions like this except. I'm not going to write it for all of them just because that would be too hard. But in this case, I think this is perfectly fine. If you are for exceptions, go ahead and just create your TCP socket. Otherwise, specify no throw and then check if it's valid or not. Let's see, what else do we need? I think that's all we need for now. This gives us all the functionality of the TCP sockets that we need. Now we can go ahead and create a resolver to get like a list of sock address ends, and that will be kind of fun for us. So I'm actually going to put it here in networking. So I'm going to add a module, remote desk, resolver. Yeah. I don't know if I should go with resolver or DNS, but I think I'll go with resolver. Just because, again, it's kind of like using the boost. I've actually thought about just using boost just to avoid having to write the low-level stuff, but it's fine. We're already done. I mean, we already have a safe socket in the WinSock library and all of that, so I figured we would just go ahead and do this. We're going to call this resolver. Now, I also may call this a TCP resolver because that is basically what it is. Yeah, I think I'm going to do that just because I only want it to be able to take IPv4 TCP, which IPv4 TCP is kind of like it's what's going to happen anyway. So, but I don't care. We're just gonna do it like this. So we need to wrap this in a namespace remote desk, and we're probably gonna have to include another header, and that header is going to be WS2 TCP IP. This will allow us to use get address info, and that's what we're gonna need in order to do this. So we're going to create a class called TCP resolver. I don't know why I keep putting a B there. We'll export this class. And what you'll see is we're still making the native interface easier to use by creating our own custom types. So this is something else. If you ever come across like an OpenSSL or FFmpeg, if you're coming across a very low-level C library that requires, whether or not like you're constructing an object, you have to do a specific thing, and then when you're done with the program, you should like clean up the object or destroy it in some way, like an SSL context or something. That would be the perfect thing to put inside of a class with a destructor. Even if you created one wrapper that just took two lambdas, an initialize, throw an exception, and a destructor, clean it up, right? Like something that simple will save you a lot of time because you don't have to worry about cleaning up the object. So that's exactly the purpose to this. All right, so we also are going to need vector. And the reason we're going to need vector is because we're going to put our sock address inside of a vector. Where are you at? I'm going to go ahead and close these because I don't need these anymore. Okay, so now we have a TCP resolver. what I'm thinking I'm probably going to do is not worry about having any private data. I think I'm just going to have a static function. It's going to return a vector sock address end, and I'm just going to call this resolve. That's going to be like the name of the function. You got to get a host and a service. Okay, so now the way that this is going to work is we're going to have one. Well, okay, we actually have to throw exceptions. We don't have a choice here. Because we're using vector. I got an idea. I can create another, like a class here, and call this results. And then down here, I can define that class. So we'll export class TCP resolver results like this. And what we can do now is we can actually return the results. And since we're passing in references to strings, the strings they already should be allocated. And even if they're not, they should be allocated on the client, well, on the caller's end. Before the function actually gets to this point, they should be created by the compiler. So I'm thinking we're good here. We can classify this as no except. It says it returns an incomplete type. Yeah, I'm thinking I'm just going to define the class here. It's a single function in a single class. I don't care about that. It's not that big of a deal. Address info pointer m address info, and we'll just simply set this to null pointer. So in the results, I think I'm actually going to make this a private constructor and just friend this to result. I may not need to do that, but we'll see in a minute. Address info results. Inline this m address info, which we'll do that up here. Okay. So that's that. We're going to need a public destructor. And we're going to get rid of move but allow, or I'm sorry, we're going to get rid of copy but allow move. So we'll do that next. So here, if in address info, free address info. Okay, that's a void, so we can ignore that. Perfect. All right, so that's the destructor said and done. The constructor said and done. Friend class TCP remote desk TCP resolver. And this way, we get access to that private destructor, or private constructor. Let's see here. So we need to disable copy because we're messing with raw data. So const results. Simply just delete that. Results. And again, we have to do rule of 5 here, which means that we have to define all 5 plus a destructor. So constructor, the 2 copies, the 2 moves, and the destructor. That's just because we have a destructor, something cleaning up resources. The general rule of thumb is you need the rule of 5. So just remember that if you ever need a destructor for something, you should carefully look at your move and your copy operations, because you don't want to mess with data or accidentally delete it on one thread and the other thread still reading to it. And So it just prevents a lot of bugs that can happen in your code. And modern compilers, even static analysis tools, they'll pick some of this up, but it's not perfect. So just make sure you do rule of five. Just make sure you create those 5 basic constructors and copy assignment operators and move assignment operators. So right here, we'll do a move. We'll mark it as no accept. We'll set the address info to std exchange, results in address info, and set that one to null pointer. Now that's done. Results operator equal results. And now, what I think I'm going to do is I think I'm going to, I don't know how I'm going to do this. I could just return the address info itself, but that's not really encapsulating anything. But I think just having the first result is good enough, right? Like that's what I'm going to say. So I'm going to allow access. And I'm just going to call this get native info. But the other thing I'm going to do is I'm actually going to allow a sock address underscore in get endpoint. And here we're simply going to do a reinterpret cast to a sock address underscore in pointer and m address info. Oh, why is it not doing? It's not doing what I want it to do at the moment. Let's still inline these. Come on. Come on, IntelliSense, because I don't remember the... I'm going to have to look this up, aren't I? When sock2 get address info, that's fine. And I hate that the news pops up. I wanted to go straight to this. I have to figure out how to mess with that. All right, get address info, returns an address info structure. And let's see, it's AI underscore ADDR. Yep. Okay, so that will get that as that kind of pointer and then just dereference, and that should automatically just copy everything. Okay, that everything looks good there. So our results are done. Again, if you need more than one result, you can call get native info, but if you just need the first one, call get endpoint, and that's perfectly fine. So now we can mark this as no accept. Oh, and the other thing we could do is we could make like a Boolean operator. Inline bool has end points. Return m address info. Does not equal null pointer. And last but not least, inline explicit operator bool. And the explicit just basically means that you can't just assign it to a bool value, but it will work in like an if statement. You have to specifically, like, explicitly cast it to a bool. We won't really get into that today. If this is too confusing, then I wouldn't worry about the logistics of this, because I know this is like, it's just an operator, but you have inline, explicit, const, no accept. Don't worry about that. Just either copy the code or reuse this whenever I post it. But this basically just prevents implicit conversions to bool. That's all it does. So now that we have our address info and we have a way to check it, all right, we can now return results. And since it's just a pointer, that class is nothing more than a pointer. Simply copying it works just fine. So now we have to get our results. what we need to do is we need to call get address info. Node name is host C string, service C string. I need to create an address info called hints, address hint, and address results, like this. So create an address info hint, address info pointer results. We'll make results null pointer, and then hint, we'll go ahead and set a couple of things here. The family, obviously, AFINET, sock type, sock stream, AI, where is protocol? IP protocol TCP. So that's the hint, and we're simply getting this into results. Here, we can just ignore this because we know it's the return results. We'll simply pass in the results. So just like this, this is our entire function. Just can also be const to know that we're not modifying this. And that is our entire resolve function. So now we can pass it like google.com and service is 80. That'd be like the port number or HTTP. And in return, we would get the IP address for google.com put into our results class. And then you simply call, first you check that the results are valid, and then you call get endpoint. Now, the other thing you can do is if you get endpoint, you can check if it's valid there, but I don't really like that. You need to check the results, or you need to have some way to do it. I could wrap this in some other thing, like a resolve result or something. But that's basically what this is. This is almost like an optional, but it's a little more specific, and it cleans up everything for you. So this is it. This is our resolve function. So the other thing that I think I want to do is I think I want to template this. And this is going to require so it needs to either be a W string or a string, and that's what's going to Now, we'll just stick with strings. It's not that big of a deal. If you're getting Y conversions, it should be turned into UTF-8 anyway, I think. So I'm not worried about that right now. If you want to add a W string version to this, just know that the results you have to call get address info W, which is this function here, and it returns a address info W all uppercase like this. Okay, but we're not worried about that right now. This is perfectly fine because, again, we're not really using it for the names. We don't need to know specific names and stuff. We just need to know the basics. So there's our TCP resolver. The next thing we need is I'm going to create a TCP client. Let's see, remote desk TCP acceptor, which is like a listener basically. I'm just going to use the Boost terminology here because those of you who are a little bit familiar with Boost, they use the term acceptor and not listener, but it's fine. Whichever one you want to call it, they're virtually the same thing. Namespace remote desk. Again, this is easier on us because we're only using TCP and we're only using IPv4. If we were using like a mix of, there's even like IPv6 mapped v4 addresses, which allows IPv4 mapped to IPv6. You start getting into complicated stuff, especially when you start getting into like multicasting. I'm not even gonna. I'm not even going to try to pretend to understand multicasting. I understand very well Bluetooth, TCP, and UDP. Multicasting, I can do it, but I don't understand exactly what's going on behind the hood. I think it's just casting multiple to like multiple socket addresses at the same time, but who knows? I'm going to call that like resumable functions. It's magic. All right, so we're going to export our class for TCP acceptor. Now, the thing that is important for us is on our TCP acceptor, okay? We need a sock address underscore n because we need a bind point. And again, like the other ones, I'm going to create two. I'm also going to do an int constant backlog. And that's for the listen part. And here I'm just going to import TCP socket. Okay, I can actually make both of these required. Like you have to give me a value for backlog. And then here I'm just going to do std no throw underscore t and mark this one as no accept. I'm going to go ahead and disable copy. Make this inline too. Now, again, one of the good things about using TCP socket is since it automatically has a move constructor, we don't have to do anything. But I would still recommend just defining it so if someone looks at your API, they understand, oh, there's something else that's being moved, and they'll see your TCP socket and understand what's going on. All right, so now the socket is going to be created here. Okay, so we cannot construct it here. Instead, we just leave it blank. And then here, we're going to construct with m. Okay, because this is the no accept constructor. So now we're constructing with no throw. The next thing that we want to do is we want to bind. So msocket.bind, bind address. And then if not, throw a system error of WSA get last error. I should put this in a function, but for now I'm not that concerned about it. And then if not, msocket.listen. Now, so there is one more thing that we can do here. If we can wrap this inside of a try catch block, so we can catch the exception here and then rethrow it. So the way this works is you do your normal constructor after putting try there, and then you put a catch block here and just write throw. And this will rethrow whatever exception gets thrown from MSocket. So I know this looks confusing, but this is how C++ does it, and it's not that bad once you understand what's happening. Just put try, then start your field construction. So you're like initializing the fields. You're creating a default MSocket. And this way, if this or any of this throws an exception, this will catch it and then just rethrow it. So this way, has no problem. But if MSocket throws an exception, Visual Studio specifically in debug mode will not allow you to catch above one scope. So this just solves that problem. All right, let's see. So here we're creating a socket. If not, MSocket return. So again, we have to do a check. And then if not, MSocket bind to the bind address. Return. And if, oh, and then we don't even have to worry about the last one. No need to wrap it up in an F. MSocket dot listen backlog. Oh, what if it, see, what if this does not work? So what if for some reason listen fails? Okay. We need a way to actually close the socket. So I'm going to come back here and say, if not, MSocket. For now, we're just going to return. And then we're going to have a bool is initialized. But see, that's a good example for socket here, right? And I'm going to go back to TCP socket actually, and I'm going to allow you to close it early. So this way we can check to see if it's valid or not, and we can wrap our functions around that. So I'm just going to put it down here at the bottom, so hopefully people won't see it, because I don't want you to close it, but if you need to, you need to. So here we're just going to call msocket.reset, and this is basically going to close the socket. It's the same thing as save sockets destructor. So here what we're going to do is, again, this is going to be painful, but it's what we have to do to be able to not throw exceptions. msocket.close, msocket.close, and obviously that one's good. And then here we're going to do inline bool is valid. Inline explicit operator bool. Okay. And so now all right, so now let's see. We need to be able to push out like a client. So when accept happens, we need a TCP client. So we are going to create a new module. We're going to call this TCP client. So remote desk.tcp client IXX. And we went over what this is. This is the global module fragment. And if you're unfamiliar with this, just watch the last video. I go over this a little bit. And here we're going to use a TCP socket. Again, we're not going to construct it by default. So a TCP client either needs to be connected directly, and here we'll just do friend class TCP acceptor. Unfortunately, I can't think of another way to do this other than allowing you to pass in a TCP socket. Actually, that probably isn't a bad idea. As just a public constructor, that does get rid of the necessity for a friend too. So I think I might do that. So we have TCP client. What I want, const socket address underscore in connect to endpoint. I don't know why that's const and not inline. And again, the no constructor. I know this is, we're writing the same constructors twice, but it's not that big of a deal. And this will allow other people to use the API if they really cannot afford to throw exceptions, like in real-time environments and stuff. We want to have that option available because exceptions are not that expensive for general-purpose applications, but in real-time loops, exceptions can be a game changer. Or a game destroyer in this case, because it can completely destroy real-time environments. So a simple branch like an if this is valid, is faster than going up stacks with exceptions. So just stack unwinding is slower. So just we want to allow opt-in, no accept constructors. It's just the way life works for us. Inline TCP client, no accept. We can simply do that. Okay, so what we're gonna do here. Oh, we need one more constructor, inline explicit TCP client, TCP socket. Okay, and then M socket. They just call standard move on the socket. Now this will be no accept just by default, just because the way the TPC socket API is written. Whenever you do a move, it's no accept. Of course, I could check it here, and if it's not valid, I could throw an exception, which actually is not a bad idea. I might do that and then have an opt-in one. No need. This can guarantee not to throw an exception. Because if the socket's invalid, then the acceptor should throw an exception, right? If you're giving me an invalid socket, that there's a good chance that that was probably what you wanted to do. I don't know. I really don't know what I should do here. I'm gonna do it. If msocket dot is valid, so if it's not valid, then we can simply throw std system error. No. If you give me an invalid socket, that's not really an error. Yeah, I'm not gonna do that. I'm just gonna make this one no accept. If you give me an invalid socket, you obviously knew what you were doing, or at least I'm gonna hope so. Because you also have to move it in here, unless you're constructing it in line. So I'm just gonna keep that exactly as it is. So here we'll construct msocket with default, and on this one, msocket std no throw, and then if not, msocket.connect. And now I know that connect is slow and you shouldn't do it unless you're trying to call. That's actually a good point. What if I just returned a TCP socket instead of a client? But I need a higher level abstraction to send data. I may actually just create a higher level abstraction to send data and you give it a socket, like a stream or something. Yeah, I think that's going to be a better idea. So we can scrap this idea of a TCP client. It's not needed. We'll just use the socket. So we have a TCP. Okay. I was like, did I just get rid of the acceptor? Put that up there. So we come back to the acceptor. Inline TCP socket, because this has all the exception handling and all that by default. So everything's good. We'll call this accept. inline TCP socket except and here we'll just simply return msocket.accept like this. That's just the standard one, and here we'll return msocket.accept. This is just in an std no throw. And this way we again have two easy ones, and this will bind and listen like in one go. Okay, so that is our acceptor. Everything looks good. So I think that's all we need. We only need one more thing, and I'm just going to call this a TCP socket stream, and it's just going to be a class that basically holds a reference to a TCP socket, and then you can send data through the stream, so you can read and write. Okay, that's what I'm going to call these. So I'm going to do remote desk .tcp stream.ixx. Or I could call it a byte stream and like take it. It doesn't matter. Let's just be specific. We'll include pch.h TCP stream import remote desk TCP socket. After this, I'll create a basic Windows socket server in another application. Yeah, and then we'll test it. And that should be the end of our networking code, everything that we need for our network, and we'll see how everything goes along from there. So export class TCP stream. Okay, so now we can't do copies, but moves. I don't need a destructor. I don't need to do anything specific here. Okay, I'm just going to have the single constructor that tells us this is what we can do. Or, I think I am going to do it. Rule of 5 still. And again, we can make these inline. Again, it's not a guarantee that they'll be inline, but it is a hint to the compiler that we would like them to. And here, TCP stream. Huh. Yep, and then if not in socket, throw std runtime error, invalid socket. Okay, and then have another one. With the no throw type. I need to start doing this too. Apparently this will check the type. Okay, and in here we don't do anything. Alright, so now we want to be able to send and receive bytes. So before we can do that, we need to do a couple of things in our precompiled header. The first thing is I'm going to refactor this with this. I'm going to get rid of thread because we don't need it anymore. So that's going to be our containers, but we also want arrays. Now we need access to standard byte and STD bitcast. I think we get both of those if we include string and vector like by default. So I'm going to stick with this and see what happens. So socket, acceptor, resolver. I'm going to say those are good. We'll test them out in a minute. Template, type name, type. We're going to say that this requires that STD is integral type value. And we'll do a size t send const type or value. Okay, so now we can either now we need something to specify our buffer size too. So we'll do a const expr int static const expr int c buffer size 1024, which is a kilobyte times 8. So we'll just set the buffer size to 8 kilobytes. I think there's going to be plenty of buffer storage. So if we're sending a single value like this, simply calling, and here we'll just return an int because that's the way the API works. So if we get an error, I think, and I'm still going to leave it on the user, or, okay, I think I'm going to have two, okay? So I think I'm going to have a send that throws an exception if there is an error, and the same thing for receive. So we'll just copy and paste this, plant that, move that over, I don't like that. And then we can receive the type. And actually, we could just have bool. And bool means that all the data send, but I think I'm going to keep it at int. And then when you receive the type, you have to pass that in. See, I don't know. Should I use a reference? Should I use pointer? Because pointer is clear on what's happening. It's clear that I am, writing into that address. Huh. You shouldn't use outs like this anyway. I think what I'm going to do here, I think I'm just going to return the type. Here, I'm going to return void. Because we're throwing exceptions, right? The exception will catch if an error happens. So this now goes away. Yep, okay. So now that we have a type, we need to bitcast it. And what bitcasting does is it will take each individual byte, depending on the platform, and align them from, I think it's least significant bit to most significant bit. So like on Windows, if you have a 4-byte integer, the far right byte is like the first byte in the sequence and it goes right to left. If you use bitcast, it lays these out from left to right. Reinterpretcast happens to do that same thing in the Visual Studio compiler. However, there is no standard implementation of reinterpretcast, and bitcast in a situation like this should be used instead. So that's exactly what we're going to be doing. So first I'm going to create a const auto buffer, and we'll construct it to be std bitcast. We'll go to an std array of std byte, and we'll specify the size of type like this, and that is the size of the array. And here the from is just value. And then we can simply get const int result equals msocket send. And here what we'll do is we'll simply send the buffer data static, or we can just do size of type and flags. So I can do constant flags equal to 0, just default them out. If result is socket error, throw a system error, WSA get last error, and system category, else if result does not equal size of type. So if the sizes don't match, like if the size that was sent does not match, we're going to simply return, or we'll throw failed to send all bytes. Just something like that to notify this. Otherwise, we don't have to do anything. Like those are the only error codes we have to check for. If the result is socket error, or the result, if the size, the number of bytes sent, does not equal the size of the type that's being sent, then there's an error that occurred. So this is our send function. So now we can send ints, int64s, and all that a single function. We don't have to rewrite it a bunch of times. Now to receive a type, this is virtually the same thing. The first thing we need is we need a buffer that we're going to be receiving into. So std array, std byte, size of type, buffer, msocket receive, buffer data, size of type. Oh, and last but not least, we need constant flags is 0. And here we'll pass in flags. We need to get our result. If result equals socket error, msocket and we want, that's wrong, WSA get last error. And std system category. I don't know why I had a brain fart there. Failed to receive all bytes. And there is something else that can happen here too, is a graceful disconnect is not technically an error, but in this case it is. So, or result equals 0. Well, here, actually, I'll put that in between this. Else if result equals 0, throw std runtime error. The socket has been gracefully disconnected. Okay, so that is the receive function. Now again, if you don't want to use this, you don't have to, but I'm thinking I may make no except versions of both of these as well. So we'll come here, and we will you don't actually need flags, because why are you peeking for an int? You should just be able to read the int. So I'm thinking I'm going to get rid of these. The no throw type here. And in here, we'll simply have a bool, whether or not it was sent, and it will simply return false, return false, return true. And that's whether or not that data was sent successfully. Now, we're going to do one for receive as well. So we'll copy, we'll paste, std no throw underscore t no accept And all we're going to do here instead, if it's an error, we'll return false. We will return false. And so return false. Return true. And we'll say value equals std bitcast. The to type is going to be type, and we'll simply pass in the buffer. That's something else I forgot in this receive. Return bitcast of type from buffer. Okay, so that is the receive, and we have no except, which returns bool. I'm thinking we'll reverse these. And still specify no throw. Just because I want to guarantee, like, I want the caller, the person reviewing your code, knowing exactly what's going on. Okay, so now we need a way to be able to send chunked data. If you provide me a vector of bytes, right, I should be able to send, 32 gigabytes over the network without a problem. And the way I'm going to do this is we set a value up here called buffer size, which is an 8 kilobyte buffer. This is going to be the size that's buffered on sends and receives. So there's actually a very easy way to do this. It's almost like an algorithm, but you'll see in just a second that it's not hard at all to implement. So the first thing we need is an inline void send const std vector of std byte. So when we serialize stuff, it should be in this format. Okay, so now that we have send, what we need, the first thing obviously, is we need a std int 64 underscore t size and we'll initialize that to 0. And you'll see what we're doing in just a minute. Or I should actually do int pointer underscore t. Now, while size does not equal static cast std int pointer t bytes, because it'll be the same size, it's just dot size return size t, which is basically uint pointer and not int pointer. So this just takes the unsigned away and returns a signed value. Int pointer is going to be good for pointer arithmetic here in a second. Okay, so while size does not equal bytes.size, what we want to do is we first need a const auto iterator, and this is going to be bytes.begin plus size. Or here, we'll do this, num bytes sent. This will this way the variable is easier to read. Okay, so now that we have an iterator, okay, so at the beginning it's going to be the beginning plus 0, okay? So just follow what I'm doing here. Const auto distance to end is going to be std distance of the iterator from bytes.end. Okay, and this is going to return the distance as an int pointer, okay, or pointer difference, which isn't pointer. And this basically gives us the distance to the end, and you'll see why we need this in just a moment. And now we can do const int result equals msocket send. Now the first thing is going to be the buffer. So here's the only way I know how to do this cross-platform. You need to dereference or get the address of the dereferenced iterator. Okay, so now we're on size. The size, it's first off, it's an int. Okay, we're going to use std min. and it's going to take two parameters: number of bytes sent and distance to the end. We also, constant flags is 0. Okay, so if result is socket error, throw a system error, and here WSA get last error, system category. Okay, otherwise, what we're going to do is we need to statically cast result into an int pointer, and we don't actually have to worry about that since they're both signed types, right? Int pointer, if you look at it, is just assigned as long. So there is an issue there. So the way we need to do this is we need to cast that to an int pointer. And watch what happens here. Num bytes sent plus equals what? Static cast std int pointer t, and we'll do num bytes. Oh nope, we'll do result. So let's say we're trying to send 8 kilobytes, okay? But we only send 3,000 bytes instead. Result will be 3,000, and we're only going to increment this. So the next loop, num bytes sent, will not be 0. It'll be 3,000, and we go from the beginning plus 3,000 to the right. And this gets us to the 3,000th byte. The distance to the end is used in the send function because we need to see exactly which one is lower. And num bytes sent almost made an error there. It should be buffer size. So is the buffer size smaller or is the distance to the end smaller? Because if distance to the end is smaller, then we need to guarantee that that only that amount of data gets sent and not the entire buffer, because otherwise you'll overrun. So this prevents buffer overrun and stuff like that. So this is the function. This is all that's necessary, and you can send over chunks of data. So if you put an entire file into a vector of bytes, use this API, it'll send it right on over without a problem. Okay, so now we want a no except version of this function. And the way to do this, though, I don't know exactly how you're going to do this other than having a bool. Or we could return a int pointer to specify how many bytes were actually sent, okay? And here, unfortunately, the only way I know how to do this is to make you classify flags. I'm not going to worry about this. This is lower level stuff here, so I'm not going to worry about no throws here. Let's just finish the receive with a throw. So inline void receive std vector std bytes. Okay, and it's basically the exact same algorithm, believe it or not. But instead of send, we're going to call receive. Now, there is one more thing, though, that has to be done here. That is that the bytes need to... So if you pass me... If bytes is empty, I'm just going to return. It's not an error to pass me empty array of anything. Or we could throw an invalid argument, which is what I think I'm going to do. Is empty. Okay, so now we have the number of bytes sent. We have the exact same algorithm. We just changed send to receive, and this entire thing works flawlessly. Except there's one more thing. Remember that it can also be considered an error if result is 0. It's not an error if it doesn't send all the bytes like the ints, but it is an error if it fails to, if it gracefully disconnects. And with this, all we're going to do is simply say, what did we say up here? I just want to copy and paste that. The socket has been gracefully disconnected. Okay. All right, this way it's the exact same error message. All right. And that's our receive function. So now we have this stream that we can get and receive data from. And actually what I think I'm going to do, these no except ones, I'm not going to do them. I'm just going to return exceptions here. If this is too high level, just write your own functions now that you're seeing exactly how to do this. Because streams, like C++ streams, they do throw exceptions sometimes, or they handle internal state which throws exceptions and they just fail. I don't really like that. I'm just going to throw an exception if something happens in a TCP stream. Okay, so I'm even going to throw an exception here. I'm not going to allow you to pass me an invalid socket. That gets rid of all of this, except for getting it. That gets rid of all of this. And now the code is so short and so simple. And we can take in any integral value. We're not going to do floating points. If you want floating points, you're going to have to serialize that by yourself. And we can send and receive bytes of data. So now it's time to actually test this out. We're going to go to WinMain. And I'm going to include a TCP resolver. And I'm going to include TCP socket, TCP acceptor, and TCP stream. Okay, so now what has to happen now that WinSock library is initialized? We need to, let's first create a TCP socket. Remote desk TCP socket. We'll just call this socket. Now, this again will create it if something happens, it'll throw an exception. TCP resolver. Again, it only has one static function. So I'm just going to do auto results google.com and I'm going to do port 80 like this. Okay, so now we have this resolve, which will return some results for us. So let's make sure that first the socket creates and that the resolver is able to resolve. Uh-oh, what happened here? TCP stream failed to do something. I don't know why it's failing. Let's just rebuild the entire solution. It's going to take a minute, but it shouldn't take long. That's right, I got rid of flags here. I got rid of flags here too, so that will be 0. Don't mess this up, make that 0. And then here we have flags, but actually I don't want flags. I want this to be a higher level abstraction, so we're just going to pass 0 for flags. And the same thing here. We don't need flags, we'll just pass 0. Okay. So now, let's go back to WinMain, let's test. See, TCP socket created successfully. There's our socket. WinSock library is created successfully. There's no limit. We're running WinSock 2.0 and it's running. Results. Here are the results. Oh, look at that. Looks like we have a valid address. So now let's try to get the endpoint. So auto endpoint equals results dot get endpoint like this. And this will return the first endpoint. Endpoint is AFINet, the port. Now again, this is a network byte order port, so this is actually port 80. So just so you know that, I can demonstrate that in a minute. But if you see here, this address, look at this value here. This is the actual address. But then if you look at the bytes, you can see it's 142.250.217.238. And that is our... By the way, you can actually get a string of an IPv4 address with a single line of code. So I'm going to demonstrate that real quick because I think a lot of people actually would like to know how to do this. C++20, we get format, and with format, right, all we have to do is to go string IP address equals standard format, and we're just going to do that dot that dot that dot that, okay, and then just simply put 3 2 1 0. And now we have to pass our bytes. So we can do endpoint dot the address. Now this is a struct that contains a union, and we have the fields here, but we're interested in the one with s_un_b, which is the individual bytes. And now just pass in the bytes in order. So now you can literally copy and paste this to make this so much easier for you. And you just need to copy and paste that 4 times. Change this one to 4. Change this one to B3. Change this one to 2. And that is your IP address. And so I will show you here in just a second. And then just to show you, we can do... well, here. I'll show you this first. Okay, so we have the IP address 142.250.217.238. We look at the endpoint, we look at the address, we look at the bytes. Now, as you can see, it's the exact same 142.250.217.238. But if we look at this number here, I know this looks crazy. So, this is used, you shouldn't really use this one. If you're assigning byte per byte, use the byte one. But either you resolve if you're trying to connect somewhere, but if you're trying to bind locally, like for a listener, but I already have a TCP acceptor that does all that for you, you just provided a socket address. And this value here gets set with socket address any, or in address any. That's the general thing that you do. And then you provide a port. Okay, so now we know that the TCP socket's being created. We're going to connect to Google, okay, using that endpoint, and we are going to receive some data using our TCP stream. So the first thing we're going to do is we're going to create a vector of bytes, and we're going to call this page data, and we're going to resize page data to 1024 times 1024, or a megabyte, times 20. So we'll resize it to 20 megabytes. Now, what we need to do is we need to create a remote desk TCP stream, I believe it was. We'll call this stream, and here we'll pass in our socket. Okay, so now we have a stream tied to this socket. Now we can do stream, and we can call receive. But before we do that now, we need to actually send out a request. So I'm going to create a string, call this a request, like this. And here we need to give it something. So we'll do get empty http/1.0. This way it automatically disconnects. Carriage return line feed user agent. Or here we do host next. So we'll do host google.com carriage return line feed. I know this is just follow along. I'm just as a basic HTTP request. And user agent remote desk. We'll just do something like this, version 0.0.0.1 or something stupid, right? Now that we have our request, we're going to send this to Google. So before we do that, we need to connect. Now that we have an endpoint for Google, we can use that endpoint on the socket and we can connect and just pass in the endpoint like this. And as you can see, right, we resolve the name google.com on port 80, which is the HTTP port. We're getting the endpoint from the results. We have this page data vector here, which is resized to 20 megabytes. We created a TCP stream. We're connecting, and then we're going to send the request.data, request.size. Okay, so we'll send over the request, which is this string here. Oh, I forgot one more thing. The end of an HTTP request, the way they know the header is done is they have a character return line feed for each item, and then you find another character return line feed. So it's basically looking for 2 of these in a row, and that's how you know the header has been terminated in HTTP. So that's what we did here. This should get the home page. So we're getting, and then blank, which just means index. HTTP 1 is set up that when we're done receiving all of the bytes, it should disconnect for us. So I'm not 100% sure if we can use TCP stream, because again, if we go back to TCP stream, we're seeing here that when this happens, an exception actually gets thrown for this, but this is probably okay, but this one is not. But it's fine for us because we're just going to wrap it in a try catch block. So we're going to try catch std exception ex, and we'll just we don't have a handle window. We will say what it is, and we'll call exception thrown, and 0 for mouse button OK. Okay, and then here on the try, we're going to do stream.receive, and we're going to receive page data like this. Okay, and everything else is just fine. So now that we've resized page data, we are going to try and get our as much page data as possible. And the stream will automatically buffer for us. And you can simply, with HTTP 1, remember, the server, when it's done sending over the web page, will gracefully disconnect. On their end, their socket will call shutdown on the send or on the receive. I don't remember which one, but it'll shut down one portion of the socket. And doing that, I think it's SD send. So when we will receive that, basically they're shutting down their send portion, we will receive our result in the receive function as 0. That's graceful disconnect. It will throw an exception, but that's fine because we will still have the data. And all I'm going to do here is I'm going to add file stream, and we're just going to write this data into a text file so that way you can see what it looks like. Output file stream, we'll just call it file.txt std ios binary, because that's what we're writing. File.write, and in here what we need to do, I'm just going to write all of it, so it's going to take a second, and it's going to create a 20 megabyte long file. See, I don't know if I like that. This is really something useful for Beast Boost, and I don't know if because the size is not determined, but I'm not that worried about it. For now, this is perfectly fine, because this is not something you should do in a real application. We're testing it right now. And here we'll just do char pointer. Okay, so we'll just create a file stream and we'll write to it. So what we'll do is we will come here. I'm not going to do it for each of those, and then we'll come down here. I don't know what that was. There was something weird. Inline function definition should not be written to module due to unrecognized expression. Oh, man, I'm not worried about that. That's argument from size to. Okay, yeah, we're good. Okay, so we have page data. We have our endpoint already. We're going to make our request. Our request now equals the HTTP request. We're going to connect to the server. We've connected. Now we're going to send to the server. Now an exception was thrown, but now let's look at page data. Boom, we have data in it. Well, message box, what the exception says, the socket has been gracefully disconnected. And we have file here. We're creating the file. We're writing the contents to the file and returning. So now we are going to come here, open folder and file explorer, and we're going to look at that text file. Okay, it's just saying that it moved, and this is completely fine. But as you can see, it like we're getting data from a web server, so the API works. It's just that the TCP stream will throw exceptions. So if you're using if you need something lower level, you have to write the functions yourself. I'm sorry, TCP stream is a helper class that's going to be used by me in my application. And yes, I don't care if my application throws exceptions. I'm going to catch them because I'm not writing a video game, right? There is a real-time thread, but that real-time thread's mainly in the client. And this is basically duplicating the output of the main monitor, stashing that, reading the bytes from that texture from Direct3D, and then putting that into a vector of bytes and sending that over the network. But even then, I'm still going to use my TCP stream to do it. The only thing we didn't do was acceptors. So we can create a tiny server client app real quick. And I think that will do it for us. So we'll close that. So all this can go away now. And we're going to re-include thread. I don't know why I didn't include it in the first place, but it is what it is. And I'll reformat the precompile header later. Right now, I'm not worried about it. So we have WinTalk library. It's initialized. We'll create a remote desk TCP acceptor. We'll call this server. Acceptor. I think that's right. Oh my god, am I going to have to Google spell check? I'm leaving it for now. All right, and now we need a socket address to bind to. So sock address underscore n bind address dot family af inet dot port equals h tons 2302, right? Why not? And dot address. Remember, this is that union I was talking about, and it's in address any. What's going on here? Oh, yeah, it has to be wrapped like this. Wow, this is so weird. So we're constructing that. There, that works. Okay, so yeah, so we'll go with that. Probably going to create a helper function for those two. So now we have our bind address. We can make this const. Look at us using modern C++. Const expert. Oh, nope. Because of that h10s function. Which we could do that ourselves on Windows. It's just byte swap. So now we have our valid port. We'll do bind address, and we'll just do 1 as our port. So now that should create the acceptor. We'll create a J thread when it automatically joins. Client thread. All right, so there's our client thread. We'll do some stuff there. So now we're just going to do auto client equals server dot accept. So now we have a client. The client can client dot receive. I'm just going to create a string, call it message. Message dot resize, because again this is like a raw buffer, 1024, and then we'll receive message dot data, message dot size. That's good for me. And then we'll message box A 0 message dot C string 0 0. Okay, so that is, we're basically just going to be getting a message from the client. That's our test for this. Okay, and now we have a remote desk TCP client, TCP socket. We'll call this socket. So now we got to create another sock address underscore n. Call this connect address. Dot family is AFINet. Port is HTTNS 2302. That's the one we want to connect to. Dot address dot UN. So again, we do it like this. And we simply are going to set that to n address loopback, which is the local address. So n address loopback. Socket dot connect to the connect address. And then socket dot std string message hello world, and socket dot send. And all we're going to do now is just we're going to send the message data, and we're just going to say like message dot size. And so that should send it. The socket, we're going to shut down SD send, or we can do both, but in my case, I'm just going to call shutdown because there's no need for me to resend anyway. And then the client will, or the server will accept the client, and then we are going to receive a message from the client and then message box that out. So it should say hello world. Not a proper hello world, but it should say hello world. And something happened. Conversion from int to uchar. Yep, okay, so I knew I had to do something crazy here. Yeah, so there's one more little scope thing you have to go through. Okay, so something bad is happening. So now we want to make sure that we get a client and all that kind of stuff. Alright, servers being initialized. Boom, let's make sure server is initialized so we have a valid socket. And it is listening, so that's good. We have a client. Right there, it's having a problem. It's trying to connect, but it can't connect for some reason. Huh. Okay, this is weird. I got it stuck in some sort of weird loop. Okay, there it goes. So we're sending him out. Let me guess, so it timed out, didn't it? Yep, timed out. Why is it not? You know what I forgot? Host to network long. See, this is why it's important to have these host to network functions. I forgot that. This one doesn't matter because it's all zeros, but it's still good practice to do it anyway. So now when we run it, everything will be fine. And I know it will because it's connected to the right address now. It's like loopback should work. There it goes. Hello world. See, that's why it's important to have these classes. So what I think I'm going to do is I'm going to create a create socket address any and create socket address loopback functions. So I'm going to create a networking utility remote desk dot socket address dot ixx, and I'm just going to create a couple of functions here. Socket address. Of course, we can create an entire socket address class. I'm not going to do that. Namespace remote desk. So we have our socket address in. I'm going to call this create any const use short port. Why can I not spell? Remember even how the hell I did that. I'm curious. Will this work? That may work. I'm just gonna make this an inline function. Let's see if these work. So this one will import create any, create loopback. So this should work. Let's come up here. So something's going on. Export module remote desk. Maybe I do need to do it like this. Okay, and then here we'll just do the same thing. Now we'll come back. I'm just going to run it and see. Okay, cool. So now we can create any and create loopback. All right, so that's the acceptor. We tested the stream, the acceptor, the socket, the resolver. Yeah, I think we're good on the networking code that we need for our application. So I guess in the next video, what we'll do is we will create a Win32 video. Also, if you guys are interested in more WinSock 2 specific programming, I am working on another series at the moment called Windows Networking in C++ that uses specifically WinSock and wrapping types and RAII types. We'll go over everything eventually, from creating sockets to the WinSock library that's in this one, to wrapping things in RAII types, to UDP, to TCP, to packet, like sending packets with like headers and stuff, which is actually what this application is going to do. We're going to create some headers for our streams. So if you are interested in any additional networking content, you can check out that new series on my channel as well. And I think from now on, I'm going to live stream this specific type of video, like for the application part, specifically because it just takes too long to move. Or when I upload a video to YouTube, it starts at 360p, which makes you cannot read any of the text. But we want you to be able to read the text, so that's why I'm going to live stream from now on, because apparently it's available at 1080p, like from the get-go. Now that the networking code is done, I think what I'm going to do in the next video is we're going to create a basic window and initialize DirectX. We're going to create a render context. So that's going to be interesting. Since the networking part of the code is completely done, I'm going to go ahead and remove all of this, keeping WinSock library, because that's going to be used in both. And I'm going to real quick create a remote desk networking. Just something that, like, if I need to use it, I can include it in one place. And we're going to export import socket address, export import WinSock library, export import TCP socket, export import TCP resolver, export import TCP acceptor, export import, I think there's one more thing, TCP string. Okay, we don't need the unique resource. So this now, inside of main, instead of just importing that, we can import the networking. So import remote desk.networking. And now I have access to everything with a single import. And it's all classes. So far I think everything's looking good. Catch me in the next video where we're going to create a Win32 window, and that's why we have this entry point. And we will initialize a render context and go over some of the messages that are important. And we'll draw our first blue screen using DirectX. So that's going to be fun. Anyway, catch me at the next video. It'll be available next week, 7 days from today. Y'all have a good one. We'll see y'all then.